Hello students, welcome back to a new mathematics program for grade 8. In this video, we're going to talk about indices. Well, this is the second and last part of indices. Remember that in the first part, we talk about the different laws of indices. In today's video, we are going to talk about square roots, cube roots, and how to relate them to indices. So, you're going to learn how to evaluate square roots of different types of numbers, how to evaluate cube roots, how to relate square roots and cube roots to indices. So students, let's begin with square numbers. This is something that you have already learned in grade 7. Consider the number 1. If we take 1, we multiply it by itself. 1 times 1 is 1. If we take the number 2, we multiplied it by itself. 2 times 2 is 4. Similarly, 3 times 3 is 9, 4 times 4 is 16, and so on. Now these numbers 1, 4, 9, 16, 25, 36, and 49 are called square numbers. They are also called perfect squares. So the number 1, 4, 9, 16, 25, 36, 49, and so on are called perfect squares. Now I'm going to show you how to evaluate the square roots of these perfect squares. I'm going to call this method 1 because afterward I'm going to show you another method how to evaluate these square roots. Let's begin with square root of 1. We have just seen that 1 is same as 1 times 1. So square root of 1 is equal to square root of 1 times 1, which is equal to 1. Square root of 4 is same as square root of 2 times 2 equal to 2. You will see that there are two similar numbers under the square root. That is a pair of similar numbers. For square root of 16, the pair of numbers is 4. Square root of 16 equal to square root of 4 times 4, which is equal to 4. Similarly, for square root of 25, it is square root of 5 times 5 equal to 5. Now tell me square root of 49. Yes, it is square root of 7 times 7 equal to 7. Square root of 81, can you guess? Yes, it is square root of 9 times 9 equal to 9. Now look at this number, square root of 100. Suppose you do not know that 100 is 10 times 10. So we are going to find the prime factors of 100. So we divide 100 by 2, again by 2. Now 25 cannot be divided by 2, neither by 3, no, by 4. So we divide it by 5. So the prime factors of 100 are 2 and 5. We can write 100 as a product of its prime factors. Remember that in grade 7, you learn about product of prime factors in the chapter LCM and HCF of numbers. Here again, we are going to use the same concept. So square root of 100 is equal to square root of 2 times 2 times 5 times 5. As we have mentioned earlier, we have pair of numbers. So if we have two number 2's under the square root, we're going to take only one of them. Again, we have two number 5, so we take one of them to obtain the square root of 100 to be 2 times 5 is equal to, of course, 10. Let's take one more example. Square root of 256. We're going to find the prime factors, so we divide by 2. You will see that 256 is equal to 2 times 2 times 2, 8 times. So we're going to consider the pairs of number 2. In each pair, we're going to take only one of them. So the square root of 256 equal to 2 times 2 times 2 times 2 is equal to 16. Now we're going to relate square roots with indices. Square root of a is same as a to the power of half, where a will represent the number for which we are going to find the square root. So whenever we need to find square root of a number, we can write the number to the power of half. For example, square root of 4 is equal to 4 power half. We are going to call this method 2 because here we are finding square roots using fractional indices. The number 4 can be written as 2 power 2. Using power law of indices, we are going to evaluate 2 power 2 power half. The 2 will get cancelled. We will end up with 2 power 1, which is equal to 2. Similarly, for square root of 49, first we write 49 to the power of half. 49 can be written as 7 power 2. Evaluating 7 power 2 power half using power law, we're going to have 7 power 1 is equal to 7. Let's take another example, square root of 100. Suppose you do not know how to write 100 in index form. You're going to perform the division. Instead of writing 100 as 2 times 2 times 5 times 5, we can write it as 2 to the power of 2 times 5 to the power of 2. Square root of 100 is same as 100 to the power of half. So writing 100 as 2 power 2 times 5 power 2, we're going to have 2 power 2 power half times 5 power 2 power half. Again, evaluating these numbers, the 2 will get cancelled. We end up with 2 power 1 times 5 power 1, which is, of course, 2 times 5 equal to 10. Square root of 256. Again, we are going to find the prime factors. We're going to have 8 number 2. So instead of writing 2 times 2 times 2 8 times, we write it as 2 power 8 power half. Evaluating 2 power 8 power half, we're going to have 2 power 4. Now, 2 power 4 is 2 times 2 times 2 times 2 is equal to 16. 225. We find the prime factors. So can you guess what will be the answer? 3 power 2 times 5 power 2 bracket power half is same as 3 power 2 power half times 5 power 2 power half. The 2 will get cancelled. We have 3 power 1 times 5 power 1 equal to 15. Now students, I'm going to show you some standard values. First, square root of 100 is equal to square root of 10 times 10 equal to 10. Square root of 10,000 is equal to square root of 100 times 100 equal to 100. Square root of 1 million is equal to square root of 1,000 times 1,000 is equal to 1,000. You will notice that while evaluating square root of 100, in 100 we have 2 zeros. So the answer is 10, where we have only 1 zero. That is, in the answer we have half the number of zeros that we have in the square root. For square root of 10,000, we have 4 zeros. In the answer we have 100 containing only 2 zeros. Same for 1 million, where we have 6 zeros, while evaluating the square root, we have an answer containing only 3 zeros. So you will see that among the standard values, we do not have square root of 1,000. Because in 1,000 we have 3 zeros, we cannot take half the number of zeros. Similarly, for square root of 100,000, where we have 5 zeros, we cannot take half the number of zeros. So we're going to consider these 3 values as standard values to be used in evaluating bigger square roots. For example, square root of 400. Instead of finding the prime factors, we can write 400 as 4 times 100. It is equal to square root of 4 times square root of 100. 4 is quite a small number. You must know the square root, it is 2. Square root of 100. This is a standard value. Square root of 100, in 100 we have 2 zeros. Of course, the answer will be 10 containing half the number of zeros, that is 2 times 10, the answer is 20. Look at this number now. 360 thousandths. We're going to write it as 36 times 10 thousandths. We're going to have square root of 36 times square root of 10 thousandths. Square root of 36 is 6. What about square root of 10 thousandths? We have 4 zeros here, so in the answer we're going to have only 2. Square root of 10,000 is, of course, 100. The answer will be 6 times 100 equal to 600. Square root of 81 millions. Can you guess what will be the answer? Okay, so we write 81 millions as square root of 81 times 1 million. It is equal to square root of 81 times square root of 1 million. It is equal to 9 times 1000. The final answer is 9000. Now look at this number, 0.64. Here we have a decimal number. We can write this decimal number as a fraction, that is 64 over 100. This is equal to square root of 64 over square root of 100. Do you know square root of 64? Yes, it is 8. Square root of 100 is 10. So we have an answer of 8 over 10. But since the question was in decimal, let's give the answer in decimal. 8 over 10 equal to 0.8. Square root of 0.0081. As a fraction, we write 0.0081 as 81 over 10 thousandths. It is equal to square root of 81 over square root of 10 thousandths. It is equal to 9 over 100. As a decimal number, it is equal to 0.09. Now we're going to find square roots using a given square root and standard values. For example, evaluate square root of 200, where you are given that square root of 2 is equal to 1.41. So 200 is same as 2 times 100. Square root of 200 will be equal to square root of 2 times 100, which can be written as square root of 2 times square root of 100. The value of square root of 2 is given as 1.41. You know that square root of 100 is 10, so we are going to multiply 1.41 by 10. The final answer is 14.1. Here, you are going to evaluate square root of 3 thousandths, given that square root of 3 is 1.73 and square root of 30 equal to 5.48. Square root of 3 thousandths can be written as 3 times 1000. It is equal to square root of 3 times square root of 1000. Square root of 3 is given, but what about square root of 1000? 1000 contains 3 zeros. While evaluating the square root, we need to take half the number of zeros, which is not possible. And you also know that square root of 1000 does not form part of the standard values. So instead of writing 3 times 1000 to represent 3 thousandths, we're going to write it as square root of 30 times square root of 100. 100, square root of 100 is a standard value. Square root of 30 is given as 5.48. So we're going to have 5.48 times 10, which is of course 54.8. Evaluate square root of 0.8, given that square root of 8 is equal to 2.83 and square root of 80 equal to 8.94. Square root of 0.8, we're going to write 0.8 as a fraction. 0.8 is same as 8 over 10, which can be written as square root of 8 over square root of 10. Now, square root of 10 is not a standard value. Hence, we're going to write 0.8 as square root of 80 over 100. This is called equivalent fractions, which you have learned in grade 7. Now square root of 100 is 10. Square root of 80 is given. So you are going to have 8.94 over 10 equal to 0.894. Now let's have a look at another example. Evaluate square root of 0.0007. You are given the value of square root of 7 and square root of 70. Square root of 0.0007 is equal to square root of 7 over 10,000. Since square root of 10,000 is a standard value, we can have the answer directly. So square root of 7 is 2.65. Square root of 10,000 is 100. So the final answer will be 0.0265. So students, now I'm going to show you how to find square root of fractions. Let's begin with square root of 7 over 9. To be able to find the square root of this mixed number, we're going to write it as an improper fraction. So 7 over 9 is same as 25 over 9. It is equal to square root of 25 over square root of 9. Square root of 25 is 5, square root of 9 is 3. The answer is 5 over 3. But have a habit of always giving your answer in mixed number. Try to avoid giving your final answer as an improper fraction. So here, 5 over 3 equal to 1, 2 over 3. So let's have a look at another example. Square root of 11 over 25. As an improper fraction, it is equal to square root of 36 over 25. Square root of 36 is 6, square root of 25 is 5. Again, we write 6 over 5 as a mixed number. It is equal to 1 over 5. Another example, square root of 4 over 9. It is equal to square root of 49 over 9. Square root of 49 is how much? Yes, 7, and square root of 9 is 3. So we write 7 over 3. As a mixed number, it is equal to 1 over 3. Students, now we are going to talk about cube roots. First of all, let's see how to represent cube roots. This is the symbol for cube roots. Here we have written cube root of a. A is the number for which we are going to evaluate the cube root. You will see that the symbol resembles square root, but we have a superscript of 3 written here. You must differentiate between square root and cube roots. So while writing the symbol for cube roots, you're going to write the superscript 3 as shown here. But before evaluating cube roots, let's have a look at cubic numbers, which you have learned in grade 7. If we take the number 1, we multiply it by itself 3 times. That is 1 times 1 times 1. We obtain 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, and so on. These numbers, 1, 8, 27, 64, 125, and so on, are called cubic numbers. We are going to evaluate the cube root of these cubic numbers. We're going to start with the first method, where we are going to find cube root of 8. We're going to write 8 as a product of its prime factors. Here you will see that we have 3 number 2 under the cube root. The answer will be one of them. So the answer for cube root of 8 is 2. Similarly, for cube root of 27, it is equal to cube root of 3 times 3 times 3. The answer is 3. Cube root of 125 is equal to cube root of 5 times 5 times 5 equal to 5. Think about cube root of 1000. Yes, it is cube root of 10 times 10 times 10 equal to 10. What about cube root of 343? Of course, it's quite difficult to know the prime factors directly, so we're going to proceed with division. We're going to divide 343 by 7 because we cannot divide it by 2, 3, 4, 5 or 6. Again we divide by 7. So 343 as a product of its prime factors is 7 times 7 times 7. Hence the answer will be 7. Cube root of 216. You're going to divide by 2 to obtain the prime factors. Now we divide by 3. Cube root of 216 is same as cube root of 2 times 2 times 2 times 3 times 3 times 3. You will see that we have 3 number 2 and 3 number 3. Cube root of 216 will be 2 times 3. Remember that I told you while evaluating cube root, whenever we have 3 similar numbers under the cube root, we are going to take only one of them as the answer. We have 3 number 2, we take 1. We have 3 number 3, we take one of them. The answer is 2 times 3 equal to 6. Now we're going to write cube roots as indices. So cube root of A is same as A to the power of 1/3. We're going to call this method 2, finding cube roots using fractional indices. Cube root of 8. We know that 8 is 2 times 2 times 2. But writing 8 in index form is 2 power 3. Cube root means power 1/3. So 8 power 1/3 is same as 2 power 3 power 1/3. Evaluating this number, the 3 will get cancelled. We're going to end up with 2 power 1 is equal to 2. Second example, cube root of 125. First, we write cube root of 125 as 125 to the power of 1/3. 125 can be written as 5 power 3. To the power of 1/3, the 3 will get cancelled. The answer is, of course, 5. Cube root of 1728. First, we are going to find the prime factors. We divide by 2. Then we divide by 3. So 1728 can be written as 2 power 6 times 3 power 3. Cube root means power 1/3. So we're going to have 2 power 6 power 1/3 times 3 power 3 power 1/3. Evaluating these numbers, we have 2 power 2 times 3 power 1 equal to 4 times 3. The final answer is 12. Now students, I'm giving you some exercises for practice. The first one, you're going to evaluate square root of 144, square root of 196, square root of 640 thousandths, square root of 0.04, square root of 125 millions. Exercise 2. You are given the value of square root of 7 and square root of 70. You are going to find the square root of these numbers. Exercise 3. Evaluate the following. You are going to evaluate the square root of the following numbers. Fourth exercise. Here you're going to evaluate the cube root of the following numbers. Students, if you want to have some more information concerning this chapter, you can consult the following websites. So students, in this program we have learned how to evaluate square roots of different types of numbers, how to evaluate cube roots, then how to relate square roots and cube roots to indices. So students, this video ends here. I hope that you have enjoyed this program. Hope to see you soon for another program of grade 8. Till then, goodbye.